First of all, I'd like to thank everybody for how hard they worked today on the linear programming problem. Thank you very much, and I want to go over that on a short video and see if we can figure it out together. And I kind of wanted to start at the beginning. Let's start with we have an airplane manufacturer. They make two kinds of airplanes. They make a camel and a hippopotamus. So let's call X. First we're going to identify our variables. X is the camel, Y we'll call the hippo. It tells us that each department has their own little restrictions, and let's go through them one at a time. Production, no more than 7 hippos. No more than, which is less than or equal to, 7 hippos. We also can make no more than 11 camels in a day. That takes care of little number 1. Shipping, they can make no more than 12 total airplanes. So if I were going to do the total airplanes, that would be X plus Y must be less than or equal to 12. So there's our total airplanes. Total airplanes less than or equal to 12. Sales, the number of, and I like to write these as I do them, the number of hippopotamuses manufactured, that would be Y, must be no more than, which would be less than, 2 times the camels. So there's number 3. Number 4, labor must use we must use more than 1,000 man hours. So we must go greater than or equal to 1,000 man hours, and it takes 100 man hours to make a camel. So that's 100x plus 200y, 200 man hours to make a hippo. We can divide all of these by 100 and get rid of 2 of the zeros, and our last constraint ends up being x plus 2y must be greater than or equal to 10. Now all we got to do is start graphing these. So I'm going to start with y must be less than or equal to 7. So y less than or equal to 7. We're going to start at 7 here, and I'm going to draw a line across. Less than or equal to 7. And looking at our, it must be a less than, so we know it's going to go in this direction. Next one, x must be less than or equal to 11. So I'm going to go up here to 11, and x must be less than or equal to 11.
Madison Wright, if you're in the building, please come to the front office.
So we know x has to be less than or equal to 11. We're going to be going that way.
Office.
Next one, x plus y must be greater than or equal to 12. Well, if I look at that, we do that by intercepts. When y is 0, x is 12, and when x is 0, y is 12. And now I can draw my line between those two, and we'll make this one a different color. We'll go from 12 to 12. Okay, that takes care of that one. Y must be greater than or equal to 2x. Y must be greater than or equal to 2x. That, no, we go start at the origin, slope of 2. We can then when y, let's say when x is 10, y must be 20, or when x is 9, y is 18. So we know it goes up to right there. We'll draw a line. I'll take my line drawer and we'll make a nice pretty one. And there we go. Last of all, we must have x plus 2y is greater than or equal to 10. If I do that by intercepts, we go x must be at 10, and y 2x equals 10, we go by 5. Draw a line from there, and we'll get that. Alright, almost out of time, but when we do these intercepts, we get this one to be 3.5 and 7. This one is 5 and 7. This one is 11 and 1, 11 and 0, 10 and 0, and 2 and 4. Then we just have to plug that into a profit function. It ends up being 300x plus 200y must be greater than 3,000. When I do that, 3,000 here, you do that and you find out that these three do not get greater than 3,000, and these three do. Our maximum profit occurs at 11 times 300